Welcome everybody. I appreciate every pair of eyeballs that joins me for the session on tweaking your modules, where the term module is to be understood in the sense of the Java platform module system. I'm basically presenting a feature that has first been published in the June release of Eclipse this year. My name is Stefan Hermann. I work for GK Software and I'm a committer on JDT. Basically, this is actually the continuation of a talk that I gave 2 years ago. So back then I spoke about how JDT embraces Java 9 and how we provide the support for this. And well, meanwhile, all of us have migrated to Java 11. And from here, adopting further newer versions of Java is obviously a breeze. Everything is compatible. Maintenance is a lot of fun, and we will all happily live ever after. Until, oops, at some points the compiler will throw at you very new, brand new error messages that you will not be able to make sense of at first sight. So we need to understand a little bit what's going on and how to help developers to master the new complexity that's in here. And to get started, I will just first clarify some of the terminology that we use throughout this presentation. Basic understanding is all code lives in modules, and all modules are created equal, except, of course, some modules are created more equal than others. And the most equal modules are those that are system modules, which are contained in the system library, also known as the JRE. They are always available for every program without doing anything, except some of them are sometimes not available. Talk about this later. The normal modules that you will hopefully develop one time are modules that are user-defined, that have a description and this new file module-info. But there's also a kind of user-defined modules that does not have this description, and a few details will have to be inferred by compiler or runtime, and so they are automatic modules. But this is the universe that we aim at, and just briefly recapitulate what are the rules for wiring these modules into systems according to the Java platform module system. Basically, it's two things that need to happen in order for two modules to be able to communicate. First, module 1 needs to export at least one of its packages. So visualized here as package A is supposed to be exported from module 1. And secondly, the client module, module 2, needs to have a dependency on the first module. In source code, it's written as requires. In specification, it's often also termed as module 2 reads module 1. And if these two come together, then all the classes in module 2 will be able to access all the public classes in package A of module 1. So this is the modular universe. But of course, while you're migrating to this world, there's a lot of legacy code still. Legacy here in the terms, it's not modular. So all the legacy. But if you think this code is not subject to the rules of JPMs, you're wrong, because all Java 9 programs and beyond are actually have to follow the rules of JPMs, even if they don't notice, even if they don't make any reference to modules. And the trick here is that all the code that is not in one of the modules above is implicitly contained in the unnamed module. And certain wiring rules apply to this as well. And with this, we can quickly go to Eclipse and just show you the conflict that I showed on the previous slide and how to resolve this. I have a bunch of projects at different versions, and what I showed you was a class that was trying to use a sex parser, rocket science, and it properly imports the sex parser and everything. And what we get in this configuration is the package javax XML parsers is accessible from more than one module, unnamed and Java XML. So what the heck does this mean, and why is this an error? So the number one consistency rule in the JPMS is that every module can access a given package only from one other module. If there's a second module that provides the same package, this is an illegal configuration. And that's what we have here. The current class can access the package JavaX XML parsers from 2 different modules. The funny thing is only that one of the modules is the unnamed module. By the way, Java-C still does not detect this error, but that's there, but let's not worry about this. And to make this error a little bit readable, let me change the configuration here. And most of the things we will do in this presentation will happen in the Java build path configuration. What we see here is I do have a dependency on the class path to a module that to a jar file that implements sex parsers, and because I put it on the class path, it is regarded as part of the unnamed module. And simply by moving this to the module path, I can make things a little more systematic and change my error message from unknown and Java XML to actually listing 2 module names, Java XML and XML APIs. And to show one more detail here is that to visualize everything that happens with modules, since June, we have a new tab in this Java build path configuration, and that's the main focus of this presentation, the module dependencies. The other tabs show you jar files, source folders, projects, etc. But on this tab, all we see is modules. So we abstract from the physical shape of how things are distributed. And on this tab, we can see, okay, I have a module Java XML, and this declares lots of packages, including Java XML parsers. And also I have another module, XML APIs, and it may be too small to recognize, but this is not a system module. It has a little A decoration for this is an automatic module. It does not have a module description, but it is inferred as a module with these properties. It also declares JavaX XML parsers. So this is a conflict. This is illegal. The same package visible from 2 different modules. So the appropriate way to resolve this new error is to simply remove the library that is redundant with a system module from this build path. And we're good. Compile errors are gone. And we can even run the program that parses its own class fast. Nothing big here. If you think migration to Java 9 will be the last effort you have, this is probably, you will probably be badly surprised. Targets are moving even after Java 9. And this is just one example, and will keep us busy for a little while. For example, this module, Java Corba, has this enhanced deprecation annotation. It's not only marked as deprecated, it tells you it's deprecated since it became a module in version 9. And you shouldn't take this warning lightly, because it's not going to stay. For removal, true is a really strong warning here. And the background, so the question in this context will be, what do people do if they have, for example, an application that uses Corba and they want to run it on Java 9 and want to run the same application also on later JREs, for example, 11? How can we make this happen? The background behind this is a JAB number 320 with the title to remove Java E and Corba modules. I learned that this happened before any of the Jakarta IE and discussion started, but of course there's a connection with this. Just a little extract from that JAB lists that mentions that in Java 9 some of these things have already been deprecated, and it lists some of the modules that really implement these different standards, and also an aggregator module that just pulls in all of these just with one name. And the main point in this JAB is to say, we will remove the 9 modules listed above. And this, if you look into the JDK Jira, is marked as resolved with the fixed version of 11. So in Java 11, none of these modules exist anymore. So I'm choosing a slightly different example, but falls into the same category, the Java XML Bind library. And I will outline a few possibilities that you have to use this library in the different versions of Java. In Java 11, this is where we're heading. The only option is to have a standalone separate library and put it onto your module path, and then you can access this and you're fine. So how is Java pushing you towards this? In Java 9, we actually have to differentiate. Am I implementing an unnamed module or a named module? In a named module, I can still say requires Java XML bind, but you will get the deprecation warning, and you should really pay attention to this. So the module is still present in the JRE, but there is this warning associated to it. So if it's still present, let's move to the unnamed module. The unnamed module can still use it, of course, right? No. The unnamed module is not as equal as the named module. It cannot see this module, and they're applying a little trick. Here's maybe more text than you can read. The bottom line is they thought deprecation is maybe too weak. We should actually push people a little harder. And so when speaking about code in the unnamed module, they simply hide a whole bunch of modules so that they are not visible by default. So the idea is that you're immediately moving to putting that thing onto your class path and be done. But there's a little backdoor. The JEP continues to say, alternatively, for example, if there's a little incompatibility between the external and the system module, you can still use the old system module while it is still there, but you have to explicitly enable the system module. And there's something like -- add modules on the command line. And that's some of the new complexity that I will be speaking about, and we try to hide from you as much as possible in the nifty details. So you still have the option to add a system module, which then leads us to the solution. Well, how can the guy in the named module migrate from his deprecated version to the future safe version? And of course, we want to also put the thing, the additional library onto our module path. But before we can do it, we have to do the inverse of adding. We have to first remove the system module, because otherwise we would be in the same situation as on the first example, have a clash between two modules, in this case even of the same name. So this is obviously illegal. First remove, but how do I remove a module from the JRE? In Java 11, there is no second option. So you have to move to this solution sooner or later. So the one thing we learned from the previous slide, that a modular system actually has two layers. There is the design level layer where everything is written in module-info, and you have this new language with all the keywords: module, requires, provides, exports, etc. But additionally, some of the same things you can also do on the command line. And I only showed add modules, but there's a bunch more of these. And this is something quite new to realize, that the system architecture in the end is not completely visible in module info, but you have to consider command line arguments as well. So how do you do the things that are said in theory when we go into Eclipse and practically want to resolve these things? So I started with a modular version. So in the named module, here I have, well, currently I still have the error message that this package is not accessible, but this is simply because I did not yet write requires Java XML bind into my module info. So if I do this, it actually compiles, but for the price that module info now has this warning: the module Java XML bind has been deprecated since version 9, it's marked for removal. So this works so far without further magic. In the unnamed module, I have the message: indeed, this package cannot be resolved. It's not found. So where did it go missing? I have a dependency on the very same JRE as in the other project. And so to look at this in our new module dependencies tab, I will first show you the not recommended solution. You can go here and see the list of system modules is fairly short compared to what is actually physically in the JRE, but there is this backdoor. We have this button, Add System Module, and this shows you the rest of the truth. These are the modules that are physically present but hidden from you, and you can choose any of these, for example, Java XML Bind. Oops, when I select one module, it actually automatically selected another module, which is because Java XML Bind has a dependency on Java activation, and this is one of the rules in this UI. We never propose any inconsistent configurations where some transitive dependencies are missing. So if you add something, all the transitive things will be proposed for adding as well. And that would resolve it. And if I would go there, then in this list, I will actually see Java XML Bind as well. But let's cancel this because this is not recommended. If there is an option without, if there is a way without these tweaks, please don't use the tweaks. But if there is not, feel free to use them. So the recommended way is, of course, here to find a replacement for this outside JRE, and I have here from the JAXB reference implementation, the API jar, and compile errors are gone here. So this is fairly easy. The slightly more tricky case is how do we migrate the modular version into one that does not use the deprecated stuff. Go to the same dialog, and so as I mentioned, we should first find, and in fact here by default we have Java XML Bind, which the other did not have, and in order to not create any conflicts, let's first remove this bundle. Oops. This module is required along the path. This is my project, and then directly to the bind module. This is just a warning. I can ignore this because I want to add a replacement immediately. Next, I am informed that if I want to remove this module, for the sake of consistency, there's another list of modules that need to be removed too, because all of them depend on Java XML Bind. So let's remove them and have this consistent state. Apply this, and really there is no longer any Java XML Bind here. And now we do the same as we did in the unnamed module, add the jar from our little helper project here. And just to verify, we again have a module Java XML Bind, and I have to tell you that there is no decoration here, so this is a regular module, not a system module. Apply and close, and this program not only compiles, but it's also warning free. I could show you for the Java 11 version, there's only this one solution to add the jar, but I will skip this for the sake of time. So, at the command line, we saw, in the UI we saw, I didn't show the command line, in the UI we saw that we can tailor the JRE to make available or not available certain modules by adding or removing, and the convenience that we provide is that if you add, it also adds required. If you remove, it also removes requiring modules. If you would do the same without this UI, you would have to use two command line options. One is fairly straightforward, add modules, except that for this version, you would have to enumerate each and every module that is in the dependencies of what you are pulling in. So there's no knowledge about this. Still, it's kind of okay. For removing, there is no -- remove module, but there is a -- limit modules, which is also a positive list of modules that you want to make available. And this list can become pretty long. Interestingly here, this option actually considers transitive dependency. So there's a little deep inconsistency, and there are more inconsistencies in this area. I hope most of the time you will not need to see these options. But in case, for example, you need to paste some command line options into a Java C invocation, we still allow you to see what the JPMS defines how these options should be denoted. And that's in this button, show JPMS options. Just for interfacing with other tools, and you see that the 2 clicks that I made end up in a whole mouthful of this limit module, and there is more things that we will hide for you. But if you need to see it, here you can check what is the equivalent, for example, if you ask on Stack Overflow and they enumerate all the options. My second example is test code. And that's a heavy-duty example here. And let's assume you're implementing a modular project and you want to separate the main sources from the test sources, and the test sources are marked. And I should say a very big thanks to Till Brüchzi, who implemented in time for the Java 9 release, that we have in JDT this separation between main sources and test sources. And only when preparing for this presentation, I recognized how vital this is for actually using the whole thing. Imagine you have JUnit on the class path, and what Till, in cooperation also with JDT debug, so through all the components of JDT, implemented that if you run a single innocent JUnit test in this configuration, it will create this full set of tweak runtime options, command line options that you probably never want to see. And why is it so complex? Why are unit tests creating so much trouble in a modular setting? So let's assume I'm implementing a module, the software and the test. This is a module that does not have a lot of dependencies, in this case, no dependencies at all. Let's assume I want to write in a separate project my test code, as we do in Eclipse, for example, no problem. This test code, of course, needs to be able to access the code in the software and the test. That module may not even have any exports. Some of the code we want to test may not even be public, so I have to put code into the same package to access some of the things. This is not what JPMS wants you to do. So there is one option that allows you to do this, which is called patch module. And this allows it that both these projects can now share packages and they can access internals because with this option, the whole thing is actually regarded as just one module. If you're looking at the test code, if you're looking at the original SUT, you don't see the test, but with this patch module, you can virtually extend the module so that the test code is part of the same module and all the internal access is no longer a problem. Great. But SUT does not have any dependencies on JUnit. It shouldn't. So how do you get this into the picture? And here we get a couple more of the tweaks that are necessary. First of all, we need to create a dependency that my test code can actually reference the test annotations, that the test code can actually use assert facilities, etc., etc. So all the wealth of the JUnit framework, we need to make accessible by this add reads. This is as if SUT would require this, but only after the fact, only after compiling the original module. But also, the JUnit module needs to access the test code, be it via reflection. So we also need the inverse direction so that the JUnit module actually has knowledge about the other module. And as I said, it requires two sides to establish the communication. Also, the test code needs to expose one of its packages. And there's two flavors of exposing a package. You can make it visible at compile time with add exports, or if it's only for reflection, you say add opens. So with these two arrows, now JUnit is able to reflectively instantiate and invoke your test. So there is a runner in JUnit. You feed all this into the JVM, and it still doesn't work. Because it will complain that it doesn't know this module. When the JVM starts, it creates a graph of modules in your system, and it starts from a set of root modules. JRE modules are root modules, and your main module is a root module. And then it looks at all the requires declarations and transitively traverses this, and these are the modules available in this JVM run. At reads, for reasons which are beyond me, is not considered in this traversal. So SUT is outside the module graph. So we need to add one more tweak and say, please JVM, consider this as one of the modules that is part of this application. Ooh, how do we do this in reality? First of all, we should be very glad that for normal JUnit tests, we don't have to do anything. But let's simulate the same thing manually now. Let's go into this working set. And our SUT is really straightforward. That is the rocket science test class that produces a greet as a result, so it is testable. Here, for no particular reason, I'm using the version with JUnit 4. JUnit 5 actually works much the same way. I should show you that this project has a dependency on the SUT project. Still, I have a compile error saying that it cannot resolve the class under test. I have a dependency on the project, but I cannot see it because that other code lives in a different module, and I don't have the wiring between these. So, tweak number one, I want to integrate both of these modules, and now I select the module that I want to augment the SUT, and this button, patch with, will pull in additional source files into that module after the fact. And I could select a source folder, but project is just fine. And if I do just that, actually, the compile error goes away. No, the compile error is swapped for a different compile error. So now we have access, and just to prove, this is even a package private class across projects, but within the same module now. So this access is allowed. What does no longer work is the access to JUnit, because the module now I'm inside the module SUT, and my class path no longer helps. And so the second tweak that we had on our slide was to say, okay, SUT, from the perspective of the test project, that's not an intrinsic property of SUT, but from this perspective, I want this project to actually have a read edge towards the module JUnit, which is an automatic module in this case. And so this compile error gone, and actually still using a little bit of JDT JUnit smartness, this test can be run, and just so you see a relevant result, there is actually a failure, but it runs, and this was our goal. The last thing to show is one step more ambitious. I want to write my own test runner. And I want to do the full wiring manually that I showed you on the picture slide. So first of all, since this is project specific, I need to repeat the same patching and read as I did for the other project, so that the two projects know each other, and so that this knows the module JUnit. That's exactly the same. And with this, I actually want to be able to run my rocket science runner, which does the typical reflection trick of class for name and get declared methods and invoke, just to call all test methods. And I want to invoke it with a simple command line argument saying program arguments is work test 4. Let it run. And no, I think I ran the wrong. I should create a new, this was a JDT test. I want to run the runner, and can actually copy from here. Create a new launch configuration for the runner and pass as argument this program. And we see, oh, my tweaks did not work anymore. And this is because SUT is not in the module graph, but I mention it in some of my tweaks, so the JVM is confused. And here I need to show you something that's still experimental. It's not pushed to master yet. In the run configuration, we need to add one more tweak, which is only relevant for running. And what I would want to do is to tell the JVM that everything that's on the module path is actually also in my module graph. Add modules, and there's a special identifier, all module path. And if I run it this way, great. Error resolved, next error. So this enables the JVM to see the module SUT. And what's still missing here is that it complains a legal access exception. The runner in this module cannot access class SUT work 4 because SUT does not export the package SUT to this module. And this is the last tweak we need to apply here. Build path, configure build path. And now this module is the one that I want to open up. And the general term is to expose a package. And code completion gives me the only package that's there. And this is specifically visible now only to the target module runner to keep the damage as small as possible. And then I have these two options. I don't care about compile time, I only care about reflective runtime. So opens is my option here. This makes the package visible. And now running the runner will actually print the same result as the JUnit view showed you before, now on the command line. Just a brief look at what are all the tweaks that we applied here. Show JPM as options. This is already a mouthful, and we're still adding more options only at runtime. And the syntax is a little bit cryptic, but you do not have to worry about this. Summarizing, if you want to be the master of an application using JPMS and not let the JPMS chase you around the block, then you really need to know all the knobs and dials that you can use to fine-tune your modular system. And for migration, it may be necessary for things like frameworks that need to open packages for reflection that are not declared, etc. Some of these things are actually not necessarily a bad smell. Some of these things are actually systematically needed. But just so you know, module info is only the design level first version of your module system. The next level is the build path, where you can add things and remove things, and where you can create new edges between the modules. And that's only relevant while you're building this particular project. And it will not be exported, so other projects do not see what tweaks you applied in this project. For launching, we copy most of, no, we can actually copy all of the tweaks that you applied at compile time. We copy this for launching as well, but still then you can add more tweaks and determine the set of root module names, and then you will have to learn some of these special names which can be used instead of a particular model. These are placeholders like wildcards, specifying a set of modules that you want to access. And if you master this, I think you should actually not be afraid of JPMS. Thanks for listening. Do we have time for a question? Do you have a question? Not at this time of the day. Under the test project? Between test projects, So the test project doesn't have module-info, so it cannot intrinsically declare its dependencies. So it depends. If these are dependencies on the class path, the trick would actually be to something like add reads all unnamed, just for this configuration where you run the tests. Or otherwise you would have to enumerate all the dependencies with these tweaks. I don't think there is any reuse of the list of dependencies of your test thing. At least I'm not aware of. Yes, please? Because then, I mean, the first thing we want to prohibit is that the main source actually access the test source, and we don't want the main thing to have dependencies on JUnit and all that. So the setup with two projects was only for the purpose of making things more explicit. Because if we have it in separate source folders in the same project, what we do behind the scenes is actually two builds. Because both builds have different... So at the surface, that's exactly what we want, and that's exactly what the separation into the source and test does. My separation into two different projects was just to make explicit how these options work, and that testing is actually a real useful thing for some of the options that otherwise look like a little bit smelly. Just as a motivation, yes, frameworks, test framework is only one. I mean, dependency injection frameworks have similar issues, of course. And yeah, sure, our goal is to not bother the user with most of this. But in case you need it, this is how you do it. No. The normal situation, a source main Java and a source test Java, if it's configured properly, all this will be done behind the scenes automatically by JDT. It is done. So if you look at the command line that is actually behind a launch configuration or generated from a launch configuration, you will see quite a sermon of things that you don't want to see. Mm-hmm. It has to be. And so thanks to Till for working. I think Nopur had her change share in this as well and for making this happen. Okay, thank you. Enjoy the last talk.